Hello, everybody, and thank you for joining. We still have some more people joining, but uh, welcome to the Buckley Associates DOAS and ERV product update. My name is Matt Halley. I'm a technical sales engineer at Buckley Associates. I've been here for almost 6 years now. I've worked in all sorts of different projects that we've been involved in, from labs, hospitals, multifamily, pharmaceutical, everything you can imagine in the commercial environment here. I'm a very active Boston chapter ASHRAE member and actually the sustainability chair for the Boston ASHRAE chapter. My job at Buckley is basically to be focused on educating the engineering community on emerging and existing technologies and providing package solutions that set our firm up for success. Let me take this off, actually. So this is actually the 52nd webinar that we've uploaded to our online training portal. So if you find this webinar interesting and want to learn more about some of our other technologies and different products that we support, please feel free to go check those out. They're really good training for new recruits, or even if you're just working on a project and interested in what we have available. And on top of that, we also have a lot of upcoming events, including our lab exhaust workshop coming up on July 9th and 10th. Those will be 2 days of the same training, but it'll be a total of 4 PDH credits available, and it'll be both in person in our training here. And the only way to get the PDH credits is actually to come into our facility and have the training there, but you're welcome to join online as well. So today we're talking about, this is our product line. I mean, and you guys might know us for our Price and GreenHeck product lines, but we have a lot of diverse and complementary product lines available too, as we kind of provide that single source system approach I was talking about. We have air distribution products, control products, and mechanical products. And today we'll be talking primarily about the mechanical products that we have available. So these are the brands here, but we'll really be talking about briefly the energy codes associated with those, changes and regulations to those equipment, and some of the new product updates with our DOAS equipment, which means low ambient control. It's A2L refrigerant performance, and a lot of the different options we have in terms of varying levels of energy recovery effectiveness, because that's a big deal with our energy code right now. So we can talk about our package units from 70 to 80% ERR, as well as our high effectiveness DOAS options with that go up to 85% ERR, and also the VRF integration with any manufacturer that comes from the factory. Then we'll continue on with commercial preconditioners, and then finally our semi-custom and custom solutions. So this is an ever-updating map. If you're an engineer designing in Massachusetts, you should recognize this pretty well. And yes, this was updated as of a couple days ago, so who knows if it's the most recent, because it gets updated all the time. I did not check this morning, but for the most part in Massachusetts, you need to be designing for at least stretch code. And then within the specialized code, there's some more requirements, but for the most part, the biggest changes to DOAS and ERV equipment is this slide right here, which talks about how now we need the 70% enthalpy recovery ratio in both heating and cooling design conditions. And it's important to note that that's a weighted average for the entire building. So that's why when we talk about high effectiveness DOAS options that we have, it could be a good way to average out that enthalpy recovery ratio of the whole building above the 70% requirement. Another small note is that you need to achieve the 15 credits as opposed to the credits originally, the 10 credits that it originally required. It's funny too, some engineers have told me that ComCheck still has not been updated for Massachusetts and still requires just 10 points. So it's important to note that for anything stretch code related, you need to get that stretch code mandated 15 points. And in order to do that, the best way to do that is actually to provide an air source heat pump with a COP of at least 1.75 at 5 degrees source air. So but beyond that, there's been a refrigerant change. The US EPA has set a global warming potential limit of 700 for HVAC systems. And this is in compliance with the AIM Act, which mandates 85% nationwide phase down in hydrofluorocarbons by 2036. So right there on the left, you'll see the right there on the left, or no, sorry, on the right, you'll see the phase down schedule. So by 2036, we should be down to 15% total HFC usage, which will help the ozone efforts there. So for us right now, the key deadlines involved is by January 1st, 2025, the global warming potential of all refrigerants we use must be below 700 for all air conditioning and heat pump equipment. And by January 1st, 2026, same rule applies to VRF. So there's a little bit of a grace period there for VRF, but it's important to understand that equipment manufactured or imported by January 1st, 2025 with the GWP higher than 700 can still be installed until January 1st, 2026. But it does need to it needs to arrive in America by January 1st, 2025, or be manufactured here by then. So it's kind of funny. What does that mean? It means a big phase out of R410A refrigerant. That's the most common HVAC refrigerant on the market. It's an A1 refrigerant, which has a GWP of 2088. That means that the A2L refrigerants will take over. And what does A2L really mean? It's just a classification of its flammability and toxicity. So a lot of engineers are starting to become a little bit concerned about it being quote unquote lightly flammable. As soon as you say the word flammable in design, people get a little bit squirmish, and Massachusetts is as well. Actually, this picture to the right here is actually, that's me with the Governing Affairs Committee at the State House, where we were pushing Massachusetts to finally accept the bill about the act regarding the phase down of HFCs. Massachusetts is actually still one of 4 states that has not adopted A2L as a viable refrigerant in the state. So fingers crossed, by July 31st, it's still the new refrigerants should be acceptable. But those 2 refrigerants that really are going to be big players are R32 and R454B. R32 has a GWP of 675, while R454B is 467. Now, don't get it confused though, R454B is actually mostly R32. It just has a R1234 YF, which is a hydrofluoroolefin. So it's basically just it really is, it's kind of a better refrigerant because it provides better compressor reliability and in wider operating ranges, and also has just a lower GWP. So most manufacturers that work with refrigerant will be going to the R454B for sustainability purposes. Some other changes in regulations: manufacturers need to now provide more realistic testing metrics per the DOE. So that means you're going to start seeing nomenclature like SEER2. So SEER has always been thrown around. It's a seasonal energy efficiency ratio, and that applies to DX rooftop units handling less than 25% outside air and are less than or equal to 5.4 tons of cooling. The original SEER testing procedures were kind of just not as realistic because they were measured without ductwork, but SEER2 uses a more realistic testing procedure because it uses the new M1 test procedure that basically adds static pressure to the system and weights it in a varying way that will provide a more realistic performance. Now, ironically, they did not make an IEER2. They just increased IEER, the integrated efficiency ratio, by 15 to 18% in 2023. And that applies to DX RTUs handling less than 25% outside air and are greater than 5.4 tons of cooling. But what's going to be more relative to what we sell at Buckley is the ISMRE, which is integrated seasonal moisture efficiency, removal efficiency, which again has been tested with the M1 testing procedure. And that just provides a weighted efficiency to measure units designed for 100% outside air and the dehumidification associated with that. So one important note about the ISMRE rating is that DOAS units with energy recovery will now require a higher minimum ISMRE2 than one without energy recovery. Because before, you could get away with accounting for the removal of humidification from the wheel, but now you will have two different ISMRE minimums for a DOAS unit. So if the DOAS unit has an energy recovery module, you will need a higher ISMRE rating. Now, at Buckley and with GreenHack, you don't have to worry about any of that because everything that we provide is way higher than what the DOE even requires. IER, we are 40 to 50% higher than the minimums on average. And then ISMRE2, we're almost up to 100% higher than what they require. And regardless of what it is, and if you've seen a GreenHack submittal before, you'll notice that we provide a compliance sheet with it. So right here, you can see that the ISMRE2 is well above what the ASHRAE 90.1 minimum efficiency says by 2.8. And then they actually give you that enthalpy recovery ratio, and they'll compare it to the IECC, or I guess in this case 90.1 requirement. But as we know by stretch code, that 50% isn't right. It's actually 70%. But the good thing is with GreenHack, and we'll get into this in a little bit, we're well above the 70% as well. So move on. So there's a lot of air handling equipment at Buckley, and I want to take a time to emphasize that at Buckley, we have a great engineering team that will help you determine what fits your project. So whatever the scope is, you can get us involved, and just send us the performance and configuration requirements. And we have a lot of people on staff to help you find the right selection. So if you're looking for a quote, on the other hand, just email sales@buckleyonline.com and we can get you a quote for that as well. So in design, we'll pretty much always go to GreenHack first if we can. It's going to be our least amount of cost, most fluid transaction with GreenHack. Not too much involved because it comes straight out of CAPS. If you know GreenHack well, you'll know that CAPS is a great selection and ECAPS, and we have a great team that can work with GreenHack really well. Now, if you need a more high effectiveness DOAS option or VRF integration, we're going to go to System Air. System Air is a $1.4 billion company. We've been representing them in some way for a long time, and they have a really great Geniox unit that I'll talk about here in a second. Beyond that, our semi-custom option or large package DX option is with Solution Air. Solution Air is maybe not as a familiar name, but they're actually part of Price Industries. Price, the manufacturer you guys all know as the air distribution, fan coils, everything like that. They are the mechanical division of Price Industries. And then finally, we have our full custom line with airflow equipment. We've been very successful with them recently, especially being in some master specifications. We'll talk about them too. But to start off, let's talk about GreenHack. Some big news from GreenHack that it's just a teaser for now, but they are going to be introducing rooftop units in the future. It's coming. There's going to be more news about it near the end of the year. But for now, this slide is going to be a good way to represent what the difference is between rooftop units, makeup air units, and DOAS systems. Because a lot of the times these names get thrown around, and they should not. They're not a direct replacement for anything. So the rooftop unit, the primary function control is to control the space temperature. The secondary function is to provide minimum ventilation air. Okay. Makeup air units, the primary function is to replace exhaust air only. It's never to condition the space in a way that is, on a psychrometric chart to get tight control. The secondary function is then obviously to get sensible temperature control, but not really have anything to do with dehumidification. A dedicated outdoor air system, its primary function is to fully condition outside air, cool, dehumidify, and heat. And its secondary function is to provide space cooling and heating. So what does that look like in a system? This diagram here does a good job of representing it, but the DOAS unit provides 100% outside air and controls the latent load. The rooftop units control the sensible load. And that rooftop unit, by the way, could be any type of equipment that does not dehumidify the air, or in other words, is kind of like a sensible equipment. So that could be chill beams, VRF, fan coils, radiant panels, baseboard heat, anything like that. And So what this means is that the temperature and humidity control are decoupled. So this leads to better comfort and efficiency. The tight humidity control and you don't overventilate the heat, which overventilate the space, which just provides better efficiency. So dedicated outside air system, the humidity control is done by the cooling coil, and then the hot gas reheat will actually, you can avoid overcooling the space with the free reheat from the DX system. And there's a little diagram up there to the right where it shows that there's essentially a second condensing coil inside the airstream that will reheat the dehumidified air so you don't overcool the space. So can this be done with the packaged rooftop unit? The answer is essentially no, because as you increase your requirement of ventilation air above 30%, you're gonna need a DOAS unit to do it effectively. And if you're wondering why would you even dehumidify, ASHRAE 62 states this pretty well, that habitable spaces need to be between 30% and 60% just because of mold growth, essentially. Bacteria, virus, fungus, everything, it fits really well into that 30 to 60%. So let's talk about what GreenHack has in terms of DOAS options. We have the models RV, RVE, and RVC. That's from 500 CFM up to 18,000 CFM, and we can do 3 to 70 tons of cooling with DX. Now, with heating options, it's not as relevant anymore, but we can do indirect gas heat, we can do electric heat, we can do hot water coils, we can even do steam coils. It's not listed there, but we can do steam coils. And most importantly, one thing to point out here is that we have an air source heat pump up to 30 tons. We can also do packaged DX and chilled water. Now, the two big differences is in our RVE and RVC is that the RVE has a polymer enthalpy wheel or aluminum wheel, and the RVC has a polymer or fiber enthalpy core. And for our market, I really want to push you towards the enthalpy wheel. There's some concerns there with it being high maintenance or cross leakage, but I want to really put a stop to that because one, cross leakage is well below what you need for even a class 3 exhaust space. And then two, we have a really great relationship with Air Exchange right down the street in Hanover. And if anything ever were to happen to a wheel, which they don't for the most part, that we could handle that immediately. But that said, we can get a total effectiveness of 70 to 80% with the wheel, the total enthalpy wheel RVE model. And by the way, the polymer version of this is actually the most economical in terms of relative cost. So all of these are available with that air source heat pump I was telling you about. In fact, it's been available for a while, but now we have the new refrigerant that I was just talking about available with it. As of in August, we'll be able to start selling it this way. The R454B air source heat pump available up to 30 tons of cooling, like I said. Lead inverter compressor standard, EC condensing fans are standard. It has the new heat pump lockout of 0 degrees, which we'll get into what the logic means on that. Single circuit design, which follows our packaged DX line, and some control enhancements for low ambient conditions. And we'll also always be able to provide electric heat, hot water, and gas furnace as a supplemental or backup heat option. So in the redesign to R454B, we've changed the circuiting and compressor quantity to basically make this thing more efficient. This helps with our ratings with the DOE, but overall, it's a more efficient design than what it was. The IEER, COP, and ISCOP2 has all increased. And those design changes come with an amazing ambient lockout of 0 degrees with certain limitations. It's important to understand that if your unit does not have energy recovery and the outdoor air temperature goes below 10 degrees, you will need secondary heat to make that work. Now, in our market, most of the time we're using energy recovery, so you're never really gonna be below, for the most part, you're never gonna be below 10 degrees with an energy recovery system in there. But again, we can always do backup and secondary supplemental heat. So if the outdoor air temperature goes below 10 degrees, then you'll need to have some sort of backup heat involved, and we can also do an electric preheat coil as well. So some control logic changes with this low ambient operation. Our cold start sequence is designed to start up in low ambient. We have a dynamic control operation that basically avoids trips upon startup at low operation condition. We do that by boosting speed, and it's enabled at 20 degrees and below. So it increases the compressor speed to move, to improve heat capacity. So for example, an R410A air source heat pump would actually be less efficient at 17 degrees. We are able to boost that temperature by quite a bit. And this is with the 17 degree ambient temperature entering the coil. So in this case, no energy recovery. With control logic for low ambient condition, let me push this through. There is, with the defrost cycle, it does switch from heating to cooling. And this is when you would need the secondary heat or recirculation during that cycle to prevent cold air delivery to the space. And really, that's really only a risk during rainy or snowy days between 32 to 45 degrees. If it's below 32 degrees, that snow will be less likely to stick to the coil. And if it's above 45 degrees, there's nothing that's going to freeze on top of it. It really would just be rain that sticks to it otherwise. In regards to the heat pump locking out, there's only 3 conditions that would really cause that. 1, if defrost is initiated 3 times in 1 hour. 2, if the outside temp is below the heat pump ambient lockout of 0 degrees. And then 3, if the supply temp is 5 degrees below the set point for more than 10 minutes, and if the secondary heat is available as backup only. Alternatively, you could use supplemental heat operation, in which the heat pump would be, it would kick on, the supplemental heat would kick on if it's only 2 degrees within set point. So defrost information, the max defrost time is 5 minutes. And when the recirculating damper is installed, the unit can defrost at 100% recirc. Move on. So now all this stuff is available to you, the engineer or contractor, with ECAPS. You can also, again, always work with us, and we can go through our actual CAP software to make you a good selection for your application. ECAPS is great because you can do side-by-side comparisons with and without energy recovery to kind of show what the loads are. But anyways, so moving on to system air. This is, like I said, this is our high effectiveness DOAS option. We have a really big airflow range with this too, from 440 CFM all the way up to 65,000 CFM. And we can do VRF integration at the factory. So this is up to 85% enthalpy recovery ratio, which makes it really good for your passive house projects and otherwise just over getting your average up on the enthalpy recovery ratio of the building. So we can do multiple different energy recovery methods with this: high effectiveness wheel, counterflow core, glycol loops. And the cool thing about this too is there's no transformers needed. There's no, like, we can do 208 volt 3-phase, 463 phase, no problem, and no electrical issues on site that way. So this is a 60 millimeter double wall cabinet. It's greater than 2 inches. And this is a modular design. It's a really great modular design. You can really build it however you need, and it can actually be assembled in the field this way as well. So it's kind of like a semi-custom air handling unit, except more out of the box, which makes it more cost effective. All sorts of different primary heating and cooling options, ERV options, like I just said. It could be DOAS or makeup air. And finally, like I said, it could be VRF integrated at the factory and can be used in any Geniox configuration. Here's an example of our Geniox System Air CAD program that is available to engineers, in which you can actually configure the unit with all the components you want to see from the factory. But then again, you know, keep us in mind as people that can do this ourselves, and we can help you through the project. Another cool option from Geniox is the oversized wheel. Instead of needing to boost that energy recovery by increasing the whole size of the whole cabinet, you can actually just increase the size of the wheel itself. This gives you a boost, an energy boost, efficiency boost of 3%. It's only about 4% bigger on each side. And then you only really get a hit with a pricing increase of about 5% to do that. So it's a good differentiator to maximize energy recovery savings, and good way to lower pressure drop as well. So the secret sauce here is this wheel. It's a Klingenberg Hugo sorption wheel. It's obviously very thick, and it's important to note too that, you know, this is the type A of the wheel. We have 4 different types. There's type A, B, C, and D. D being the least effective but lowest pressure drop. So let's say you don't need the absolute most efficiency, energy recovery efficiency. We can actually downgrade that a little bit to save on the static pressure. There's something worth noting there. So this wheel is also used in our TopX unit. So in both of these ceiling and standing models that are intended for indoor mounting, we get high effectiveness from that wheel that I just showed you. We can also do a sensible core out of this, and eventually we're working towards doing an enthalpy core. But these are airflow ranges 400 to 4,000 CFM. It has EC motor technology, and we can integrate these with VRF as well. It's just a little bit different because it's kind of mounted to the unit rather than inside the unit at the factory. These do come with tempering, or you can do it as just a preconditioner. So this is the TR, the one that's standing right here. This is the TR. They call it the mechanical room the mechanical room ERV. It's very compact and very configurable to make it a pretty good installation. A lot of different components. As you can see, one thing I like to point out is that these can come with 12-inch deep filters. These fans are robust. They needed to make it through that high efficiency wheel and a big filter. And then there's some heating and there's some heating options as well in this. And then, like I said, if you were to see if I can do it. If you were to do a VRF coil, it would go just right about here. And then we could mount the LEV kit nearby. So this is what it looks like. This is just an example of what it looks like. Top connections, shallow depth. It's really just really good for mechanical rooms. Now this is the TopX. The other one I showed you, this is the one that goes in the ceiling. It's the most compact, high output ERV in the market. You know, for a 4,000 CFM unit that can go in the ceiling, 33 inches depth is really not that bad. And all access is on this double access door right here. So pretty good overall. And here is another component list, similar, where the fans are robust. And as you can see, the model I'm showing right here is showing a dual wheel system, and not a dual wheel in the typical DOAS reference, but actually in line. So the airflow would go through both these wheels. That's what gives it the very high effectiveness that I was talking about earlier. Here's an example of what it looks like. This is the biggest one. So as you can see, and here's the access that I was talking about. You'd be able to access both sides from the drop down right there. So beyond that, some other preconditioners I want to talk about are from GreenHeck. Now, GreenHeck has a whole line of core preconditioners as well, but given our market and given the effectiveness we need, these preconditioners can all get above 70% ERR, and we can range from 150 all the way up to 12,000 CFM. And frankly, these would be probably our most economical options for you. We're very competitive with these, and we can meet the effectiveness you need. We can provide EC motors on some of them, economizers, and BMS integration. The ERVE model is great for the airflow we can provide. Again, greater than 70% enthalpy recovery ratio, depending on the performance. The ERV model goes up to 12,000 CFM, EC motors, and we can provide controllers with these as well. And those controllers can actually activate heating and cooling coils downstream with BMS compatibility. The mini vent is one that I really want to draw attention to. This preconditioner is a great option for anything below 900 CFM. And I'm going to show an example in the next page, but again, Green EC motors, frost control. Usually the controls would be by others on these units, but let me show you a quick example. The mini vent 750 Green is sized for 900 CFM and 0.5 inches water gauge. And granted, that 0.5 inches of water gauge is, in this case, low. I should have honestly selected it for more, but this is just a really good example of how we can select even it's funny, it says 750 in the name of the unit, but obviously this is sized for 900 CFM, which is the high limit, and we can already get the enthalpy recovery ratio in the conditions required. So at 0 degrees dry bulb, outdoor air, we can still get the above 70% enthalpy recovery ratio needed. And this is at a very economical, cost-effective option. So moving on into our semi-custom options, we have solution air. We can do some pretty high airflow units with solution air, up to 120 tons with digital scroll compressors. We can do 18-to-1 furnace turndowns on indirect fired units with even 90% efficiency from that. They're low sound condenser fans, highly engineered structural steel base, 2 inches foam panel. We can do these stacked or side by side or knocked down. Now, what I've been using them for especially is on our exhaust plenums when we pair them with GreenHeck vector systems, where we use the wraparound heat pipes. But we can use these for any type of energy recovery option you want. So this is where GreenHeck ends their airflow capacity currently at 18,000 CFM. We could go well beyond that with solution air and even up to over 100,000 CFM. So here's an example of a project we did at 64 Pleasant Street. Just an example of one of the DOAS units we did there. And here's the team visiting in Winnipeg, Canada. So again, this is at Price. This is Price's facility up in Winnipeg. So just us doing some quality control, making sure everything looked good. Everything went in without a hitch. We're very happy with the way these units turned out. So we also have full custom options available too from Airflow Equipment. Airflow Equipment is based in Kalamazoo. They've been operating out of there since 1985. They've been doing customizable hospital and pharmaceutical grade air handling units for a long time. We've been able to show these units to a lot of hospitals and engineering firms in the market, in our market in Boston, and we are listed at the master spec as an option. We have a few basic design projects that we're working on right now, and we've done a number of projects already with them. They really specialize in hospital and healthcare, pharmaceutical, and then higher ed and some research laboratory. But it's important to note that they can build a steel spec, or they can build an aluminum hospital grade spec as well. So they also specialize specifically in knockdown units. So if you ever need a good knockdown unit, this is a great option. Here's an example of just a supply air handling unit we did that tied in with a exhaust air handling unit. So, and we can work with any type of coil, whether it's a control package from another manufacturer, we can tie that in, no problem. And that actually is what I did on this project. This is at 5-Channel Center in Southie, I guess Seaport. It's in Seaport technically. And here's us visiting to make sure that all worked out well. We did a different manufacturers, a different reps coil package in this one as well. So usually I have a lot of questions in a meeting, and this time only went about 40 minutes, but I hope if you guys have any questions, please feel free to reach out and give me an email at mhalley@buckleyonline.com, or give me a call and we can talk about it. But I appreciate your attendance. And again, we have a laboratory workshop that will talk about a lot of the stuff that I just showed on July 9th and July 10th. And I'd love to see you guys there. Thanks for coming.